Welcome back to Practical PyTorch. In this video, we build a convolutional network in PyTorch. You have already met the pieces: convolution, activation, pooling, and a linear layer. Now we put them in an order that works, wrap them in a class, and turn a batch of images into class scores. This is the whole model, 5 pieces in a row. An image batch comes in on the left. The first conv block, a second conv block, then flatten, one linear layer, and 10 scores come out. You have met each piece already. This video puts them in an order that works, then adds the classifier on the end. Do not worry about the numbers on the arrows yet, we get to those next. This video has 3 parts. First, the architecture, 1 block at a time from the input to the logits. Second, we build it as a class and read the shape trail, checking every shape against the figure. Third, we get the flatten size right, the one bug that catches everyone once. First, the architecture. It starts with a batch of color images. The batch axis B rides in front, and here B is 4 images at once. Then 3 channels, then the height and width 32 by 32. So the shape is batch 3, 32, 32. That order batch, channels, height, width holds all the way through. For now, just the input. The blocks come one at a time. The batch flows into the first block along this arrow. The arrow carries the shape going in, batch 3, 32, 32. The first block runs 3 layers in a row, a conv, a ReLU, then a pool. The conv grows the channels from 3 to 32. Padding keeps the size, so the map stays 32 by 32. The ReLU keeps the positive numbers and drops the negatives. The 2 by 2 pool halves the map. 32 by 32 becomes 16 by 16. So the block sends out batch 32, 16, 16, and the next arrow will show it. The output of block 1 flows into block 2 along this arrow. The arrow carries batch 32, 16, 16. The second block is the same 3 layers. That is the point. The conv grows 32 channels to 64. ReLU again keeps the positives. The pool halves the map again. 16 by 16 becomes 8 by 8. Smaller map, more channels. Out comes batch 64, 8, 8. Now the maps flow toward the classifier along this arrow. The arrow carries batch 64, 8, 8. 64 small maps for each image. The linear classifier wants a flat vector, not a stack of maps. Flatten unrolls each image's 64 by 8 by 8 into one long row. We flatten from axis 1, so the batch stays in front and everything after it folds into a single row. How long that row is, that is the whole story of part 3. The flat row flows into the linear layer along this arrow. The arrow carries batch 4096, one long row per image. 1 nn. Linear reads that row and outputs 10 numbers, 1 score per class. This is the same classifier head from playlist 1, only wider on the input side. Where 4096 comes from is part 3. The 10 scores flow out along the last arrow. The arrow carries batch 10. These 10 scores are the model's answer raw logits, 1 for each of the 10 classes. That closes the pipeline. An image batch in, 10 scores per image out. The figure is whole now, and every later slide reuses it. Now let's build it in nn.Module. The whole model fits in one class. In init we name the 4 layers. the two cons, one pool, and the linear head. In forward, we wire them in the order we just walked. Block 1 runs the first conv, a ReLU, and the pool. Block 2 does the same with the second conv. Then we flatten, and the linear turns the row into 10 scores. Notice one detail. Self-pool is defined once and used twice. Pooling has no learnable weights, so the same layer serves both blocks. This is the shape after every layer printed. It starts with the input, a batch of 3 channels, 32 by 32, the same shape on the first arrow. The conv grows the channels and keeps the size, 32 channels, 32 by 32. ReLU does not change the shape. The first pool halves the map, 32 channels, 16 by 16. That matches the arrow leaving block 1. Block 2 grows the channels to 64, and its pool halves the map again, 64 channels, 8 by 8. That matches the arrow leaving block 2. Flatten folds 64 by 8 by 8 into one row, 4 by 4096. And the linear turns each row into 10 scores, 4 by 10. The block outputs line up with the arrows in the figure. Now part 3, getting the flatten size right. The linears in features is the flatten size, channels times height times width of what arrives. The last conv block gives 64, 8, 8. Flatten turns that into 4 by 4096. And the arithmetic checks out. 64 times 8 times 8 is 4096. Python says true. So the linear takes 4096 in and gives 10 out. You can see in features is 4096 in its repr. Feed the flat row through and you get 4 by 10 as expected. And the whole model is just 60,362 parameters. Now the most common CNN mistake. Suppose you hardcode 4096 because that was right for a 32 by 32 image. Then a 28 by 28 image arrives instead. Run it through the same 2 blocks and flatten. Now the row is 4 by 3136, not 4 by 4096. The linear was built for 4096, so it refuses. The error says it plainly. 4 by 3136 and 4096 by 10 cannot be multiplied. So the rule is simple. Never type a number from memory. Work the flatten size out from the channels, height, and width that reach the linear, and it moves whenever the input size does. Let's review. A conv block is conv, then ReLU, then pool. Stack the blocks, and each one shrinks the map and grows the channels. Then flatten, and one linear turns the vector into class scores. And the flattened size is channels times height times width of what arrives. Read it, never guess it. Next, we train this CNN. Your turn. The last conv block gives batch 6488 and you flatten. What in features does the next nn, linear, need? Pause and work it out. Okay, here it is. 64 times 8 times 8 is 4096. So in features is 4096. But it is not a constant. Change the input size or add one more pool and it changes with it. Read it off the printed shape. Do not type the number you remember. That is the whole model built and checked. Next, we train it. The same 5-step loop from playlist 1, a real dataset and a gap that opens up as the model trains. That is the next video. See you there.